Find the answers to questions you may or may not have asked yourself. Here at Kaleidoscience, Conversations on Cognitive Science.
In a previous episode, we already talked about Parkinson's disease, but we were mainly focusing on diagnostics in this episode. But in today's episode, which is part of our block of season 2 about applied science and technology, we are talking about technology that can help to diagnose and to aid people who have Parkinson's disease. And for that, today we are talking to Christopher Gundler. Welcome.
Thank you for having me there. We're here.
And as always, at the beginning, we play our short get-to-know game, where I'm going to give you 5 sentences, and you can finish them as spontaneously as you may. And the first sentence is, as a kid, I always wanted to be.
A paleontologist. I think that was the first word I was able to spell, actually. And one friend of mine just got this friend books that try to put that in Germany. It's just that long word and so obscure order of chars in there. So I quite like dinosaurs. So
Okay.
found it always interesting to see how you can combine science and the fiction, a bit of art there.
Yeah, I see that. That changed after a while, apparently.
Yeah, actually, yeah. I did a school internship during school within the archaeology department, but on early archaeology. So actually, they are moving stones from left to right. It's extremely interesting, but probably not the way of work I wanted to do for my life. You really needs the eye and patience of an amount I do not possess. So that was the end of that.
Our second sentence is, if I was an emoji, I would be.
Oh, I think the boring smiling emoji one.
Which one? There are a lot of boring smiling ones. Which eyes? The eyes are important.
Just the usual slightly smiling, friendly face. I'm an emoji kind of person, sending emojis actually everywhere. Probably not as bad as some boomers there, with emojis within the text, but at least in the end of my messages, if they are longer, there's normally a friendly emoji. So
Okay.
just a friendly, smiling emoji one.
Our next sentence is, my favorite thing to do on a day off is.
Actually going hiking, I suppose. I like to be in nature. A bit ironic that I live and work in a large city like Hamburg, but there are even here decent ways of moving inside the green.
Our next sentence is, right now I'm most fascinated by.
Alternative ways of representations for complex data, I suppose. Learning something what we as humans would name probably knowledge, but with computers. And there's quite a hype around generative AI learning those representations, and I'm a bit curious about the applicability of those systems in medicine, and I try to create probably or use alternative there.
Mm-hmm. Are you generally skeptical about generative AI or?
Personally, I think generative AI is actually the kind of AI we are able to some extent to get into healthcare, right? Rather than those discriminative systems before. That's to the point normally completely away from the reality. However, I think, especially if you just use always something like latent representations for this stuff, we are actually interested in clinics. We have a really hard time getting such systems, for example, certified. And if we are able, for example, to use those complex systems, deep learning, as the things they are amazing in, as feature extractors, right? And then extract something there which is more formal, which we can, apply actually the methods on the AI community is working since the 70s. Then I think we have a combination of both the hot topics, so to say, which can really solve problems unsolvable before, and still put that on a foundation where we can make informed decisions qualify, for example, uncertainty, all the stuff we actually need if we want to build something which we bring into clinical practice.
Yeah. I think we're going to talk about clinical applications in much more greater detail later. But before, our last sentence. I know it's time to call it a day when.
I think I would answer the question actually when I sit on the bicycle on my way home, right? So I have something like a way to travel between the University Medical Center and my home of about 10 kilometers or something. So I need, in Hamburg with all the traffic lights, around 30, 40 minutes. And well, sometimes, as you know already, in academia, you take long days. And if I sit on this bicycle and drive at, I don't know, 10 p.m. home or something, then and feel the cold wind actually around, especially now to this time of year, I always know that's amazing. Now, if I arrive at home, it's warm there, probably the bed is waiting for me, and it's amazing, right? It's the end of the day, it's a cool day, you have got a bit of way of moving and using energy you do not use when you sit just on this chair. So this bicycle, right?
Nice. You've already mentioned that now you're living in Hamburg, but you actually started off at some point in Osnabrück as well. Could you maybe tell us a bit about what you did in your studies and how you ended up what you're doing now?
Sure. Actually, I always laughed regarding cognitive science that it's that broad, right? So when I started the bachelor, I really had to look around. And for example, I figured rather early that I'm horrible in philosophy of mind. So much things just were to some extent checked and then never used again. And I ended in the direction of computer science, which I did before as something like hobby projects already, and artificial intelligence in a rather, I would say, strict sense, in the sense that that was most systems where you put quite much human knowledge into, right? And then you get systems which do not require that much data, for example, and work quite well. I studied then in Auckland and on a semester abroad, as most Coxis probably do. Focus there a bit on computer science, on computer vision. Sorry, did some work there as a Hiwi, and actually then ended during a bachelor thesis in a small company in Osnabrück. And I wrote a nice bachelor thesis there. I stayed there during my master's, and afterwards, took over the small AI team within that company. So we built systems with had mostly already an AI background. For example, we created a project where we tried to infer concussions from eye movement. And that was actually quite amazing, right? Because it was so much Coxi related stuff you can put there and try really to help people. I think academic world is always interesting, right? Because you can do the research you find interesting, but it's completely different if it matters for others. And in the medical domain, normally you have the beautiful opportunities that both match quite well. So I had some nice time actually there in industry, so to say, not on longer in the academic area. However, I found it quite difficult to some extent there because we have in Germany not a problem probably with the amount of data, but for example, with the availability of data. And especially if you are a young startup, which does not have that much money to fund large studies with university medical centers, you have a bit of problem, right? Because as long as you're not a medical product, you cannot get into studies normally. And as long as you are not there, you cannot get the data you probably need for your data-driven approaches. So it's an egg problem somewhat. So I found a nice alternative after moving to Hamburg here at the University Medical Center. Well, did my work here, and I'm now the leader of the team for applied AI and healthcare here at the Institute for Applied Medical Informatics.
As I already said in the introduction, you are currently doing a project on Parkinson's disease. Can you maybe remind the people or the people who haven't heard the first episode that we did on the topic what Parkinson's disease is and what it's maybe like, what the key symptoms are that people often associate with it?
Parkinson's disease is a rather heterogeneous group, so to say, of symptoms. So it's extremely patient-specific, and in any way, it's normally disease, so to say, caused by dying neurons within the substantia nigra in the brain, and you get actually loss of important neurotransmitters, which you can, to some extent, for example, try to substitute with medications, which works to a certain degree. Then you can use alternative techniques like deep brain stimulation, where we, for example, here at the medical center do much to try to stop the progress of the disease, or at least slow it down, because we can still not treat the disease as it is. And so regarding the symptoms, you have an extreme broad scope. You have different subtypes. Prominent are really motor symptoms. That's probably one of the diseases which are most knowledge regarding motor symptoms. You may have such things like tremor, actually, so involuntary rhythmic movements. You may have something like a rigor, actually, which is not quite the opposite, but to some extent, actually, where your muscles are working against each other, and that manifests itself then in something like, or the missing ability to move, for example, parts of your hand. You have, if you're wrongly treated and you get, for example, too much of a drug called levodopa, then you may have dyskinesias where you actually are over moving. You have something like a rather, it's hard to describe, but you will probably see it when you see it. It's really over movement, where people move probably their arms, their foot, when they're normally not expected to do so in society, and that already figures or give a clue probably to the other problems associated with the disease, because there are many non-motor symptoms, and as far as we are concerned, they are really a challenge. We have much research regarding motor symptoms simply because you can measure them. You can place some wearables, what we actually did too, or some other fancy stuff. You can use voice, for example, amazingly to figure out in which state a Parkinson patient is. But the non-motor symptoms, like different kind of pain, different kinds of depressions, an influence on the quality of life reported, that's normally far more complex to measure, and with much confounders, so to say, from the environment.
You already hinted at the fact that diagnosing Parkinson is really difficult, or can be difficult. When is the point where people detect it, and how is it detected? Like, do people already go to the doctor with like these symptoms and rather late stage of Parkinson's disease, or is there like a test you can do to check if you have it or something?
Yeah, the nice thing with Parkinson's disease is actually that we have a quite bunch of tests, and they are sometimes known since the 80s. So in the case of the UPDRS, and that's normally amazing. Well, I work at the Institute for Medical Informatics, and most of the jobs we have to do before we can do any analysis is interoperability. And those tests regarding the data rate and reliability and all the stuff, they are normally quite good in providing interoperable results that we can, for example, use large observational studies. However, when actually a person is diagnosed, it depends hardly. So I'm not a doctor, I'm not diagnosing people, but as far as I know, there's a rather broad scope of patients, and they come really in different kinds of ages. For example, there are early Parkinsonism already observed in the end of the 30s if you're extremely unlucky. So it could be that age. Most of them are older, actually. But it's quite in scope, for example, or quite a range when people normally observing the first symptoms and then untreated.
Which are the symptoms people usually notice first?
That's actually a good question. I actually have to guess. So normally will be probably those related to the motor symptoms. So, and they are, however, rather late. right? So in the scope itself, so the early we assume there's not that much evidence for that, so we do not know how the non-motor symptoms develop, but there's large evidence that they develop earlier. This early onset Parkinson, but the people normally get treated when there are motor symptoms, because then, for example, you can do those tests where you actually just give the drug and you see if there's, for example, an effect of that.
And is motor system always related to large movements such as leg movements, arm movements, or can it also be smaller things such as facial expressions, tiny movements, etc.?
Facial expressions is a good keyword, actually. Hypomimia is really a problem where we observe that the people does not show the amount of mimical expression we would expect them to show. And that's a symptom. That's the reason why it's good probably that we talk about it now, that it's somewhat between those motor and non-motor symptoms, right? Because in this moment where I do not show emotions, it's always a bit difficult of saying if I, for example, feel the emotions as I would feel them if I show them, right? We probably know this amazing experiment where somebody is not forced, but somebody is motivated to take a pen in his mouth and he's smiling, and then the brain actually registers, oh, okay, he is moving his the edges of his mouth upwards, so probably he's smiling, so probably he's happy, and that's back trigger, so to say, and that's probably the same with hypomimia. So they're too much present in mimic. That's of course bad in the social context, because we as humans normally would accept that there's an expression of joy probably if I tell you something happy, or another expression, and that's missing, and it's of course difficult for the person itself.
So is it they don't show enough mimic compared to what you would expect, or do they show more?
To a hypo, so not enough.
Not
so
enough.
Less than we would expect.
And do we know how far that is related to Parkinson's disease? So is it because they can't control their muscles, or because they don't realize?
There is some evidence regarding the general manifestation of those symptoms in Parkinson. However, that's still up to debate. So we know, of course, what the major reasons are. We do not know, for example, for sure how it develops, the disease, and so there are many grayish and blackish areas there regarding how it manifests. And as I said probably in the beginning, it's extremely dependent on the patients. So you have something commonly like tremor dominant patients, for example, versus non-tremor dominant patients, and also so there's a good chance that you probably never experience such symptoms, or at least not in that strong sense as other might experience it. And it's now something you already assess, for example, within these forms like the UPDRS, which is probably one of those gold standard, the third part of it for motor assessments, and it's part of that. But there's not much work on that, of course, because it's particularly hardly measurable, and the doctors tell us that they have difficulties identifying it, comparing it, and then there comes this inter-rater or missing inter-rater reliability in there, that we get a test which we cannot probably interpret all the same.
You already said that it's hard to measure, but what is the process of measuring it? Like, are there like electrodes connected to the muscles, and we see how much we use the muscles, or what is the usual way of measuring things like that?
I would say the normal way of measuring is just looking in your face. So doctors just use they probably name it experience. I would probably name it gut feeling plus experience. So they have, of course, seen many patients, and they assess that on some rating scales. So, for example, for tremor, it's a bit different. That's normally assessed that way too, right? Just by optics. But however, because it's oscillatory movement, we can measure that by electrodes, for example. And then, for example, the the rating scales are defined then sometimes regarding, for example, the amplitude, if larger than 1.5 centimeters something. But in that detail, that's not used normally in hypomimia.
You are now bringing, well, we've talked about that you were interested in AI when you studied and that you're now working in the medical informatics department in Hamburg. I guess you are still somehow working with AI in the whole context of Parkinson's. How can AI even be applied in medical contexts generally?
Generally on Parkinson's.
First general, then Parkinson's.
First general, then Parkinson's. Yeah, well, our mission as a team here at the Institute is to bridge this gap between what's possible in theory and conducted in reality, right?
Mm-hmm.
Because we commonly see that in science we are optimizing for other objectives than those we need in reality. So what we are doing is normally not inventing some new fancy architecture or whatsoever. We are more in, probably understanding what others are doing and then modifying it or applying it to the task we actually see there by hand. So that's sometimes support in clinical diagnostics, of course, like in this Parkinson game, but it could be completely different things. So that could be, for example, just think about project we're actually tackling right now, something like support in creating interoperability in texts, because the medical world especially suffers from missing interoperability and still suffers. It's always a problem. Or it can go to the monitoring of lab animals, right? So they are normally overseen, that's an issue too. But of course, in our medical progress still depends on lab animals, despite the fact that we are doing amazing, also UKEs, for example, doing amazing job in do research on so small micro organs, so to say, where you can already test substances on. And for example, we track these animals automatically to see if they are well. So that's another way of bringing actual medical informatics into practice. And well, of course, in Parkinson's, and that's, well, it's hardly conducted in reality by now. However, we have an amazing scope of work already in there. So Parkinson's disease is, regarding all the way of measuring it, well understood, and in clinical trials, for example, already to some extent administered. And we were quite interested in how well those things perform if they are used outside of those controlled environments. And for example, here in Hamburg, we have somewhat a focus on Parkinson's. You can probably say that within our neurology department. For example, we offer patients, in German term is Parkinson Komplexbehandlung. Actually, it's something like a treatment where the people come here for normally up to 2 weeks, and we are working all the day in different kind of setups with them, getting used to the disease, optimizing the treatment, right? Because treatment in Parkinson itself is a challenge.
Mm-hmm.
Because you cannot create something like the gold standard, so to say, of treatment, and then just stick to that. That won't work. And our first work in the world of Parkinson's was actually a project we had here with the pharmacy, which was about printing 3D medications depending on the symptoms of Parkinson patients.
And how far printing 3D medications?
Where probably in the therapy of Parkinson's disease, you always have this narrow band of optimal treatment. If you're treating not enough, you have those symptoms like rigors, for example, right? Mm-hmm. Or probably observing tremors, or something called freezing of gait, where people actually stop and then probably may fall over. And however, if you give too much, you end in the dyskinesias, where you're actually over-treating patients with some effects, or besides the motor symptom in the system itself, right? Because if you replace dopamine, you may get something like unusual behavior in terms, for example, of gambling too. you might get that. So it's always balancing in this small window between those extremes, and you always have to adopt that. And the idea was actually to, well, monitor motor symptoms of patients based upon that information, check if the current, for example, dosage of levodopa is still enough, and then if it's not, get an option to send information to a doctor who says probably we need to increase the dosage by 0.5 milligrams. And that is then printed with a 3D printer for medication within the pharmacy, which is something our pharmacy is quite good at, and which is not conducted, I don't think anywhere else in the world, actually. That was a large EU project, actually, where we then got the AI component, so to say, up and running.
You already said that you are not like developing new ways of doing artificial intelligence, but you are looking for ways to apply the knowledge that is there to actual medical use cases. Why is it, or but for me, it feels like that has been done very rarely. Maybe like the only field where I have heard like of AI applications is like in radiology, looking at images and doing diagnostics from that. But apart from that, I've rarely heard of any applications of artificial intelligence in diagnostics or in medical care in general. Do you think that there is maybe a trust problem, that people think like, oh, AI is so unreliable and we cannot um, put this very important aspect of our life into the hands of artificial intelligence? Or don't you think that there is really a hesitation to use these new technologies?
I don't think there's really a hesitation, neither from the doctors nor from the patients, if you conduct it properly. So we now, for example, out of our experience with Parkinson patients and smartwatches, for example, they are normally extremely happy just to be part of a small study, right? So they do not get anything from that. And we explain them, of course, okay, there's something like machine learning running in the background, which may you do not have any bad effects because it always runs through a doctor, and you probably will have no effect for you personally at all, but at least we collect, for example, data. And I would guess 99 out of 100 patients are fine with it, completely fine. They're normally having fun trying something out. The problem is that there are areas for AI in medicine which are well suited, and those which are probably in the naive setup not well suited. And the thing and the groundbreaking success, for example, of AI in radiology is due to the fact that it matches the processes well within the radiology department. So if you have a look, most of the, for example, by the FDA clarified or certified AI projects or products, they are mostly radiology based, because the system just mirrors what we are doing here at the hospital. So there are radiologists which do this complete day, often nothing different than just getting their feedback regarding some images they see, and they can amazingly be supported there. However, on the other hand, from this neurology, from this radiology this perspective, we already know what kind of biases there are, right? Because when you give persons, doctors, experts a system in their hands, you may get, for example, all kinds of biases that people overlooking things, for example, which they normally won't overlook. I found always a bit difficult that, you give doctors a tool to their hands. The software companies, for example, creating those tools say, well, it may replace doctoral knowledge up to a certain point. However, you still put the doctors in the loop, right? Because the doctors are then still in the loop of supervising those algorithms. And that might work well in radiology, might give useful hints if you consider all the things regarding usability, right? Probably let the doctor, for example, decide first, then check the result with an artificial intelligence, and if the model then knows, there's probably an area where I disagree with the doctor, probably show a hint, for example, something like that. So you get AI in a better way into the system. And out of that, it's quite difficult, right? Because we need trust in the system, and our system, as we have it in the medical area and in our society itself, it's all based on taking responsibility, right? And there's no way for current systems, so to say, to take the responsibility. And as long as the systems and the developer won't take responsibility, for example, the health insurance companies won't do anything with that. Because we see, for example, even without any artificial intelligence, the number of patients getting a second opinion, for example, by a second doctor is rising, right? Massively rising, and it's good. Especially, for example, in oncology, where the treatment of the patients outside of university medical centers is sometimes up to 10 years older than the current state of the art. And it's good that people check that, be skeptical. So this God of in white image, it's somewhat away, or at least retreating. And we cannot establish then something like an artificial intelligence as a second God in white. Won't work.
When developing medical devices that use AI, how do you make sure that in the end the device is safe to use and doesn't, like, that the data or the output the device is giving is more helpful than harmful?
You normally never trigger an action directly on the data, for example, you could record by those devices. You can probably aggregate them in some kind of form where you can present them to the doctors to say, well, have a look there, have a look there, have a look there. And actually that already classifies them as a medical product of the second order, so to say. However, then there is somebody in the system who actually presses a button to do something like that. And that's a good thing, even outside of the AI bubble. One have to know one of the largest or most dangerous parts in hospital regarding mistreatment is, for example, regarding substances, pharmacological substances, which some effects doctors were probably not aware of. And for example, here in the UK, we established once, I think we were one of the first university medical center in the 80s or something, where there is something like a loop system where a doctor, for example, says, I want to prescribe medication X, puts it in the system, then there's a pharmacist actually looking that, checking that, and then it goes in the system and it's if given out, for example. So even with humans, there are two kinds of professions in line. And for an AI system, it's actually the same. So at least you put at least one extra human in the loop. Or like in the case of Parkinson's, probably even more, because the pharmacy is involved too. So by that, you always, on the one hand, have more option, more expertise. On the other hand, you have, of course, something like this responsibility, because in the end, the doctor then is taking the responsibility for the treatment he is administering.
In what you've just said, you said that, or responding to the earlier question about the trust in AI, you said that many people in your database or people that you treat use smartwatches, and you have some AI algorithm that does something with the data. But earlier, when we were talking about hypomemia, you said that it's usually like something that the doctor sees visually with their own eyes. Are there other smart wearables or any things that use AI that can be used, especially in Parkinson's disease, apart from smartwatches?
Yeah. Probably, as we pointed out, so due to the dominance of the motor symptoms in research, you have quite an amazing pool of tools, at least in the experimental setups in hospitals. For example, smart inlays for shoes, for getting steps, right? Because the freezing of gait, where the people just stops actually when she or he has to think about conducting an action during or directly after walking, they are quite harmful for the patients and normally really a downer for the quality of life, for example. So you can try to measure that, for example, by putting sensors in your shoes. There are all kinds actually of wearable devices in all parts of the body. So not only as wrist, but for example, on the ankles and on the belly, in time of the belly that you get, where the center of the body is, so to say, for example, in relation to the feet, sorry. There are devices which are more extending, so to say, the body, like spoons, for example, for eating, which try to remove the tremor signal, because otherwise people can hardly eating, for example, soup, just because there's spilling it everywhere. If we are able to get a feeling of this oscillatory movement, we can, of course, calculate it away. And if you see those videos, it's amazing. It's really cool to see. We're not doing anything like that, but for example, that's our really products you can buy by now. So they are quite well established. And regarding the smartwatches, that's of course nice because there's something like a market around. So many companies by now have smartwatches which are at least tackling not only the home setup, so to say, but studies, right? So I was this year on the large conference, probably the largest conference on movement disorders, and I think there were 5 different companies selling some kind of smartwatches for studies. I personally do not know if they will remain that, or there will remain that many companies, because I think the market is quite low and now shifting more towards this home-based devices. However, there's something to get there. And for example, we of course are most interested in smart textiles. So we try actually to build a cap where we get something like a camera within the rim of the cap and then film the face, get a feeling of how facial key points actually move during interaction.
Can you maybe describe to us how this cap looks like? So like you mentioned, there's a camera. Is there anything else people should know when they imagine the cap?
It's actually a good question. Currently, it's not a cap itself. The problem with the cap is that you, of course, need to be able to wash it, to disinfect it. That are now those problems which are normally overlooked in science, right? Because in a study, I can, in theory, just get 50 out of them, put them on the heads, and then just throw them away afterwards. Not good for the environment, but happens. If you want to apply it in reality, you probably need something different. So what we actually have is now something like a brim you can put on the part of the cap, and you can just place it on. It's currently rather heavyish, so we need to get it smaller and finer, but for the prototype phase, probably fine. And we have a 3D printer here, so actually we're 3D printing all the time this plastic prototypes. And that's an amazing thing we can do nowadays, right? Not only here, but I think many startups, many companies, many research teams all around the world have now the option to get quite early into prototyping cool devices, because both those PCB boards are easily makeable nowadays as 3D printed cases and whatsoever. And then we place such a custom device PCB board in there, which both camera and actually a movement measurement sensor, that we can track the position of the cap within a word frame, that we get a feeling not only on what's the face of the person, but in which situations she or he is actually.
Is the environment measurement also by camera, or is it more?
And no, that's not even something we want to have. We have, of course, to write ethic proposals, right? And if I would say I film around everybody, whether he likes or not gonna happen. That's really just about the kind of movements a person do with the cap, right? If she's moving or he is moving, for example, or probably being rather steady and then just move the head slowly during conversation.
And what is the use case of this measurement? So is it used in diagnostics, or does it help to fine tune the treatment? What use?
What we are doing now is quite early, right? So that's something we are currently still working on the ESIC proposal. It's I think the second or third round, so that's normally a round-based thing. But that's normal, right? So that's not even despite the content of the proposal itself. We will first use it within the motoric labo of the Parkinson facility. So where the people normally get at least 1 or 2 complete measurements, so to say, often before and after a deep brain stimulation operation, just to get something like the gold standard regarding the therapy before and afterwards for seeing improvements, for example. And we will probably tackle the setup, just keep it, get it during the normal examination, actually not interfering at all with the examination, despite the fact that the patient is now wearing a cap. And then in the first run have an option to check if the things we are measuring correlates with the information doctors measure. And we will specifically look on the way different doctor measures stuff, right? Because so we have N patients, M doctors, and then check, how is the reliability between those doctors probably regarding different scores, and how well is our camera. And probably can already say that the camera is, or the machine learning model behind the camera is probably already measuring approximate as good for the specific kind of symptom. And with that, then of course, one could think of making it smaller. That would be our dream. And then probably put it to, for example, on the heads of patients which are not as closely monitored as here during their therapy, because they live somewhere else and probably see the neurologist, their neurologist outside of the hospital, only every 6 months or something, due to, or 3 months or something. It's probably quite difficult to get appointments with those kinds of doctors. So that would be, of course, our dream, that we measure it rather smallishly, just as a small thing, but generate data outside of the setups where we normally observe these patients.
And how fast, or one problem with machine learning algorithms that is usually discussed in media is like how much energy they consume and how long some of the computations take. Are your calculations then done locally, or do you just take all the data and put it into a computer and then you run the algorithm? Like, where is the actual processing of the visual information done?
Good question. Actually, we do it on the smartphone. So normally there's a smartphone coupled with the device, and there we come back to this trust thingy we already discussed, is of course an amazing option to get the patient some kind of control. So the patient is always able to see all the frames, for example, recorded, and the patient can say, I do not want that to be included. I don't know, I sat on the toilet and something like that. So then they can really remove that. And by that, we create a transparency, which is, good for the patient, of course, but of course good for all regulatory bodies too, like ethics commissions and certified bodies. So the machine learning model itself, I don't think that will be a large problem. So we won't create this feature extractor for facial features. They are amazing ones, even open source out there. We probably will test them regarding bias, especially with this cohort of, normally probably a bit elderlish people we have here normally in the state of disease. However, then that could really run sometimes on the embedded chips within the smartphone and won't possess much energy. And the actually algorithm then for detecting large or less large deviations regarding mimic is probably rather simple. I don't think that will be deep learning algorithm. We didn't create that by now, so as I pointed out, it's really something like a study going on, but I won't see any need for that, because when we get something like nice representation like facial key, key points, normalize it appropriate. So I think just for example, the difference on a reference phase during time would be already an amazing marker for such things. And then they were back in the discussion that we combined again something complex, get information out of the images, combined with something simple we can validate, and then can sell it to regulatory bodies because you can have a look what's going on in between. Not an end-to-end learn system, but rather a system we would write as in software development with different parts. And unit tests for all the parts and integration tests.
You mentioned a bit earlier that each patient is really individual, especially with symptoms, etc. Does CAP or the data the CAP provides potentially help to provide better treatment as well on the long run, or is it not clear yet because you're still testing?
I cannot, of course, promise anything. However, if we would, for example, have a way of diagnose hypomemia in a way which is working across different doctors, and if you even change your doctor for, I don't know, because you're moving, you're still able to get exactly that result as before, and that gets then as information into the process of getting the optimal treatment, I can certainly see that there are many benefits associated with that. So yes, probably the answer is yes.
Elisa, do you want to still ask anything? Because like this is also already the answer to the next question we wrote down as to the advantages of it. But yeah, I mean, I'm assuming that's it, like having a more consistent treatment.
I think I'm pretty much through with my questions as well. Do you have anything else you would like to add, or where you feel like we didn't cover that part at all?
Actually not. I think especially probably that's just a giveaway, so to say, or something. It's not an advice. In the medical informatics community within Germany, which is rather a small community, there's much going on. So we as universities are normally a bit separated of all the stuff you do when you put your card, for example, in some machine within your doctors. However, those areas are growing together. And for example, by next year, we will, for example, first in the German history have something like an electronic health record for everybody who wants it and who does not opt out. And I think the only thing I would always say that people should be aware of this data and think about this data. And normally they should be assured that everything is safe regarding this data. So they could, I think, give a bit of trust. However, in any way, it's fine if they do not trust, but they should be just aware of it. And by now, with all the trace of data we're actually generating, and the data we generate now with consumer smartwatches, for example, is still, or is getting larger than actually anything we measure in hospitals. So everybody is creating such a trace of data, and yeah, I think should be aware of it. And of course, do not hesitate to offer it. If, for example, a doctor is interested in getting heart measurements of a non-certified device, the doctor need to get that into his head. Of course, it might not be as accurate as a real device, but I know some doctors which are really happy if patients would provide them that. It's just about something like being open regarding the data, and then find the best way of getting the best for oneself, and of course potential for the whole society, which always lives actually from the data of the individuals for creating something like medical progress.
Yeah, that would be the next whole topic of personal informatics and
personalized medicine, exactly.
Yeah.
And we are doing much there too, right? So that's especially interesting if you figure out, for example, for those deep brain stimulation, that's other work we're currently doing within my team, regarding getting, for example, estimates on what will be the quality of life after the operation. Because it differs, of course. It's probably the expectation you have are not always fulfilled, right? And it's, especially if you're older, it's not an easy operation. If you have ever the chance to be a witness of such an operation, it's amazing, actually. I did it once. I saw how that is meant, and it's crazy what modern medicine is able, because actually there are a whole bunch of experts there, and you figure out where to place the electrode in the beginning of the operation, of course. But then there's a person, at least here at the EPE, who is constantly listening to the white noise, the electrode going through the brain of the patient during the operation and during the operation itself. And then given this information of the white noise he hears, and then probably ask the patient to just move your left feet to your right feet, because you're also aware during this kind of operations, he can then say, well, you probably operational list, whatsoever the English word is, you have to place the electrode 0.5 millimeters more to the left or to the right. It's amazing. It's quite cool to see. That's really cognitive science in a nutshell, in working in a living organism. It's amazing. However, it's complex operation and not for everybody, especially if you are, for example, have other difficult conditions. But getting a bit of feeling there on how to get the best out of all patients, or for the best for the specific individual patient, is really something which is A, data-driven, and B, something we will observe, especially in our lifetime now. So I think we are living in the right time of medical progress. Just thinking to oncological progress, for example, we have there.
No.
And with that, we are coming to the end of our episode. Is there anything that you would say, if somebody has listened to this episode, that they really should take away from this?
Probably a bit of awareness, of course, regarding diseases like Parkinson's disease, or motor diseases at all. They can have completely different reasons, but don't put, so to say, for example, a stigma on these patients, right? We know from quality of life assessments that stigma is really a dimension we are, for example, ask on this PDQ forms, for example, for assessing quality of life, because it's sometimes a problem. And I think being aware, of course, of motor problems of themselves and probably of others is always a good start to do not try to draw conclusions from the motor to the non-motor behavior, for example, of a patient. Because, for example, in this hypomimia example, that's probably an extreme case. That's might not probably not what the people really feeling. So the kind of expression is, so to say, a bit. It's hard to phrase it not in a way which assumes a good or bad. It's different, right? But other than that, I think it's always nice. So of course, it's not nice getting into a hospital, but I given the expertise, even as a non-doctor I see here, it's always interesting what we can do nowadays. Can do probably by the help of assistance systems, which will never replace a doctor within our lifetime. It's always dangerous to say something like temporal assessments, but I bet for, I don't know, a beer somewhere in Osnabrück, Grüner Jäger, Essacher Luft at Grüner Jäger, probably, if it happens during our lifetime. But just being open-minded, be aware of their own data, as pointed out, and probably be if there's are no reasons against, even willing to donate it, given all the circumstances one can observe them. But
you already mentioned cognitive science, and as we are a cognitive science-based podcast, we are really interested in what the people think cognition plays in their topic they are currently researching. So what do you think what role does cognition play in your topic?
Well, I think the cognition, or what we call cognition, is the key if we want, for example, to get AI-based systems into practice. So, because cognition is so much more than just, spilling out a diagnosis. It's much about reasoning, learning, getting experience, understanding environments, and all those components, they are neglected, for example, in many of those papers which are floating around, which actually makes them not applicable in medicine, right? With all this consideration of processes there we have in hospitals. So I think when we get a better feeling of this extreme broad image of cognition and identify central features, we can really learn what we expect from an artificial intelligence-based system to be a reliable assistant, for example, within such sensible areas as medicine.
That being said, I think we do come to an end. Thank you so much for being here and taking your time to talk to us. And we take your word that we see us in the Grüner Jäger in Osnabrück if AI ever is the only taker of, well, is ever the one making all the decision in medical care. But if that doesn't happen, yeah, it was really pleasant to have you here and talk to you. Thank you so much.
Thank you so much.
You've listened to Kaleidoscience, Conversations on Cognitive Science, hosted by Elisa Palme, Sönke Lülf, and Sophie Kühne. Produced by Clara Kühne, Imogen Hüsing, Elisa Palme, Leslie Wolk, Sönke Lülf, and Sophie Kühne. Produced in collaboration with the Cognitive Science Student Journal. The music was produced by Jan-Luca Schröder. The logo was designed by Annika Richter. Thank you for listening and joining us on our journey through conversations on cognitive science. This podcast is not sponsored and does not give us any financial profit. If you wish to support us, the most effective way is to do so by leaving us an up to 5-star review on your chosen podcast platform and following us on Instagram. You can reach out to us via mail, comment on YouTube, or message us on Instagram. We are always happy to hear your feedback. Thank you again for listening to us and for your interest in science. If you have any questions regarding this episode or any of our other episodes, feel free to reach out. You can reach out to us via Instagram by sending us a direct message at kaleidoscience_pod or write us an email at kaleidopod@us.de. You can find both links to our Instagram and also the email address in our show notes. We do read all your comments and will also reply to you as soon as we can.